All right, so we're talking about math library characters and strings. The math library in Java is a built-in library that's available to you just from the JDK, similar to the scanner object that we used before in order to read from the console. Okay. So again, the math library, it's built in, it's available to you, and it has a lot of different functions that you can use in Java. So for example, there's math.py. It returns roughly the value of pi, right? The value of pi is continuous. Unfortunately, computers cannot go continuously. So it returns an approximation of pi, but it's good enough for most equations, most, um, you know, whatever you're trying to calculate, the circumference of the area of a circle, it's good enough. Math.pow is to do the power of. So you do x math.pow parentheses, whatever your number is to the power of y, or the power of 2, power of 3, whatever it is. You have a couple of trig methods, sine, cosine, tangent, radians, all that good stuff, degrees. I've never used these, but they are available to you as programmers. Say, for example, you're a mathematician or you're doing something relating to math and you want to make a program that calculates the cosine of something. Well, there is a function for you to use. And again, I imagine many calculators have these functions built in. Exponential methods, you have math.pow. Of course, that's the one I was talking about earlier. Math.square root, you can do the square root of something. And you have several other ones. Again, most important ones are math.pow and math.square root. Those are the other ones we probably will not use in this. Actually, I know for a fact we will not use in this class. But they are available to you as programmers. You can round things down. So math.floor rounds it down, right? Regardless of whatever it is. So even if I have 7.9, it's going to round it down to 7.0. Math.round, on the other hand, it rounds it as you expect. So if I have 7 now, it's going to round up to 8. If I have 7.2, it's going to round down to 7. Right? Again, these are just functions at your disposal as programmers. Math also has a built-in random function. Now, I introduced you all to the random object. So you remember random, rand equals new random, all that good stuff. I did it like this, random, rand equals new random, if you recall. That's one way of doing it. Another way of doing it is doing math.random, math.random. However, math.random only returns a random number between 0 and 1. With this up here, you can get an integer, you can get a double, you can get a lot of different values from this one. Math.random only returns a random number between 0 and 1. All right. So we'll move on to characters. And when I say character, it's what you are thinking. It's one single character. It can be a letter, a number, a special symbol. It's a character. All right. And we represent characters with single quotation marks. And the data type is char or char, however you want to say it. Char letter equals A. Char numchar equals 4. Both of those are characters. Again, it's one single character. That's a character. Note the single quotations, double quotations would make this a string, which is what we'll talk about next. Here are some methods that you can use for characters. You can ask if it's a digit. If it is a digit, it's return a true. If it's not a digit, then it's going to return a false. Is it a letter? And digit, number. Is it a number? Is letter returns true if it's a letter or false if it's not. You can also ask, is it a letter or digit, right? So for example, if it's a special character, this will return false. If it's a letter, it returns true. If it's a digit, it returns true. Is lowercase, is uppercase, or converted to lowercase or converted to lowercase, uppercase. So let's just do this real quick. So char number equals 4. So system.out.println number.isDigit. And system.out.println number.isLetter. I think you have to import it. Java use character dot is digit. I believe you may have to import it. Oh, never mind. You don't have to import it. It's a different way of writing it. So you're not importing it. You're passing it in is digit number, is letter number. All right. So you do have to import it. I thought so. All right. Import java.util. Import java.lang. Basically, this asterisk right here, or star, the asterisk just says to import everything in. All right, hold on a second. It cannot find the symbol. All right. Character.isDigit. Character.isLetter. Hopefully this works. There we go. All right. So we create our character. It's a 4, so that's a digit. All right, imagine that's going to return true. The next line will return false. All right. Edit code. Let's say is digit or letter. I believe that is the syntax. Is letter or digit. Now both of these should return true. True, true. So it is as expected. It is a letter or digit. Right. Let's change this. I'm going to make it a special character, a slash, a forward slash. So both of those should be false. False, false. Right. It is not a letter nor a digit. All right. Let's move on to strings. So a string, if you think about a string, it is a word. It can be an empty string. It doesn't have to have anything. It can be a sentence. It can be a paragraph. So when you break those down, a word is basically composed of characters. A sentence is composed of characters. And so that's what a string is. A string is nothing but individual characters smashed together. And it's separated into a list or an array, right? In programming, an array is simply a list, right? So let's take this string, for example, welcome to Java. If we break it down into its individual characters, we have a W, E, L, typo, O, M, E, space, right? Space is a character. In computing, space is a character. TO space again, JAVA. It's nothing but individual characters. As such, we can retrieve each one of those characters by its index. It starts at 0. Anytime in computing, we always start at 0. Right? It starts at 0, which is W, and each one of these characters has a unique index, all the way to 14. So overall, the overall length of this entire string is 15, but notice the indices go from 0 to that length minus 1, which is 14. Okay. Because we include 0 in these indices, we're going to go to length minus 1. Overall, there are 15 individual characters, but our indices go from 0 to 14. So keep that in mind. That's important. Our indices always go from 0 to length minus 1. Overall length is 15. Indices go from 0 to 15 minus 1, or in other words, 14. Keep that in mind. That's very important as we talk about arrays later in the semester. So how do we get the overall length? Well, we say string.length, right? How do we get an individual character? We do that string.char at or char at whatever index we're trying to get. So for example, let's say we have welcome to Java. Remember, it is size 15. Indices go from 0 to 14. So we do char first equals hello.char at index 3. Well, it should return 0, 1, 2, 3, a C, right? If we do index 3, it should return a C. If we do index 7, it would be that space, because those are our indices, 0 through 14. All right. And remember, if you think back to last class, we can concatenate or add strings together. So if we say string A is welcome, string B is to, string C is Java, if we concatenate all three of these together, our final would be welcome to Java. Right? We're adding them together as you had expected. String B has 2 spaces in here, so that's why the last final string has those 2 spaces as well. Okay. So if we do final.length minus 1, we get that last character, right? Final.length, we added, I'm sorry, let me go back. So with our final, we did plus equal, and we added this right here, period, time to do some learning. So now final equals this full string right here, because we concatenated those together. If we do final.length minus 1, that last index, because remember, it goes from 0 to length minus 1, the last index would be G. Time to do some learning. All right, so let's look at that. Let's create a string. String example equals, this is programming at Shaw U. All right. Oh, I don't need that. This is programming at Shaw U. That's our string. So if I do char random equals example.char at, I'm going to say index 5. I don't really know what that is. Somewhere in there. Let's do another one. Char random 1 equals example.char at Let's do, hopefully there's a 9. Then char random 2 equals example that char at. What I'm going to do is example dot length minus 1. And it is a method. All right, so char at 5. So T 0, 1, 2, 3, 4, 5. I expect it to be P. Yep. Char at 9 is R. So I'm assuming this R right here. The last one should be an exclamation point. Exclamation point. Here we go. Exclamation point. And yes, it is. So the last one is an exclamation point. That's it. So I'm just showing you the different methods you have at your disposal with strings. And that strings are simply composed of characters. That's it. All right. Next, let's talk about comparing strings. So you can compare strings to one another. So s1 dot equals. So whatever your first string dot equals second string. So let's say, for example, I have, not this, I have string example equals, this is a string, right? Let's do string example 2 equals, this is not a string. It is a string, but then we do system.out.println example.compare to, dot equals example 2. Just looking at these, it should equal false, right? They don't equal one another. So we go through, we create our 2 strings, and it equals false. All right. We do this again. Now they do equal one another. So I expect it to equal true. True. All right. All right, let's keep going. You can do equals ignore case. So obviously that ignores any capitalizations inside your string. So this is a string. If I just do dot equals, again, this will return false. See, it returns false. However, if I do equals ignore case, I expect that to return true. And it does. All right. Again, these are just methods at your disposal. I'm not saying we're going to use these, but they're good to know. All right, you can compare to, so say, for example, you want to organize your strings alphabetically, right? You can compare them to one another. So for example, where is it? For example, this is a string, dot compare to. If I'm not mistaken, capitalizations go before lowercase, but I may be wrong. So if example 1 goes before example 2, this should return a -1, I believe. If they're equal to each other, it should return a 0. And if example goes after example 2, it'll return a 1. Or just a negative number, not a -1. If it goes before, it returns a negative number. If it goes after, it returns a positive number. So, like I said, capitalizations go before lowercase. That's why we return a negative number. Okay. If I set these equal to each other, it should return a 0. Yep. If I change this up to be lowercase instead, it should return a positive number. Yep, positive 32 down here. So that's how you can sort strings using the compare to method. If this string compared to this string equals negative, then I know the first string goes first. If it's positive, then I need to swap them. If they equal each other, then they just equal each other. It's a 0. You also have compare to, ignore case. Again, that ignores the case, just like the equal to. You have starts with, so does a string start with this? So for example, let me edit the code. So does example start with example 2? I imagine that's going to be true. It is true. We also have something ends with. Now this is going to be false. It doesn't end with that. That's false. It does, however, end with ing. Let's try that. Come on. I think it froze. Let's try this again. String example equals this is programming at Shaw U. Let me use that one instead. String example 2 equals, I'm going to just say AWU exclamation point. Just random. Then system.out.println example dot ends with example 2. That should be true. It is true. Right. If I take this off, that should be false. It's not exact. It needs to be exact. Although this is within the string, it's not exactly the ending. Okay. But there is contains, so I can't ask, does it contain this? Dot contains example 2. That I imagine would be true. It is true. Okay. I can also ask, does it just contain A? Again, I think that's true as well. It is true. All right. Again, these are just different methods at your disposal when comparing strings. You also have something called substring, which gets a substring, so a smaller string of another one. So let's say example 2 equals example.substring. And if you remember, our strings, each character inside our string has an index. So I can get the first one all the way up to the 5th one. And I'm going to get that substring, and I want to print that out. All right. And the substring is this. And I believe there is a space in there as well. It's a space, so we don't see it. So let's do substring to 7. Visualize. This is. I could change this up, and I could just do substring from 2 to 7. Go forward. Is. Right? That's not right at all. Let's do 2 to 10. I don't know why I did is. I don't know why. Oh, I know why. This, the is from this is being printed. Is PR. All right. That's why it's saying is down here. So you can get a substring of another string depending on what you want. You can also, I believe, here's just another example. If we have string hello, welcome to Java, string middle equals hello.substring index 8 to 10. So we do 8 to 10 uninclusively though. So we're going to do 10 minus 1, so 8 to 9. All right. And that's the end of that slide. So one last thing I was going to do before I end the class is, what is it? Not replace, but I think you can find string, Java find character, index of. And actually, we're going to talk about that later, but you can also do index of, and it's going to get the first index. So for example, let's say I want to get the first space. So int index equals index of the first space. Now I want to print that index. I got to import that. Import java.lang. And I'm just going to import the whole thing. One more time. Oh, that's my issue. Example dot index of. Example is my string, so I'm calling dot index of the first space, and it should be at index 4, right? And you have other methods at your disposal. You can get all of the spaces with that index. You can, cut a substring of it. There's a lot of things you can do, but just in review, we have characters and strings. Strings are composed of characters, and each individual character is indexable. So from 0 to the length minus 1. That's the main takeaway for today. With that, that'll end what I have for you all today. Are there any questions? All right, if there's no questions, I'll give you your time back, and we will meet again in class on Friday, face to face. Just FYI, on Monday is a, what do they call it, a mental
Wellness day.
Wellness day. So we will not have class on Monday. So you have something to rejoice about. But